What was he one?
Ya karen ke certificate के कारण करते हैं
Want to go?
भैया पढ़ के सिर्फ पढ़ के फ्रॉड पता है पश्चिम दृश्य
Muốn kêu cô ấy? Không á?
ya खाने
Chị bị ác hút.
era porque le
Vijay Rahul.
Good afternoon, all.
Good
Honorable
afternoon, madam.
dignitaries, honorable dignitaries, and dear student friends, I wish you all a very good afternoon.
Lokeshwari ma'am.
Yes, ma'am.
Shall we start the meeting, ma'am?
Ma'am, yes, ma'am, we can, ma'am. மேம் ஆல்ரெடி எம்சி படிச்சிட்டு இருந்தாங்க மேம். எஸ் மேம், திருப்பி நான் படிக்க சொல்றேன் மேம். அது ஏதோ வியூ ஆகலையாட்டிருக்கு. எஸ் மேம், we can
Okay.
start, ma'am. We are starting now.
Okay, ma'am.
Sir, we
Okay.
are
Hello.
starting now, sir.
Hello.
Hello.
Hello, hello, hello,
Sir,
everyone. Starting now.
it is late.
Honorable dignitaries and dear student friends, I wish you all a very good afternoon and I'm happy to see you turn up this session. We are all happy that we are entirely getting benefited out of Dr. W.B. Granul's words, and I once again welcome you for this wonderful session. When you put together deep knowledge about a subject that intensely matters to you, charisma happens. You gain courage to share your passion, and when you do that, flows follows. Such a charismatic person is our Professor Nirmala ma'am, head of the department. I request her to give the welcome address.
Good afternoon, all. I welcome you all with a pleasant greeting for this national webinar organized by the Department of Science and Humanities. We are happy to have with us our chief guest, Dr. V.B. Gormal, Professor, Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur, for this session. It's a great fun to know what we had many number of responses for this national webinar on advanced multifunctional materials, emphasis on nanomaterials. It's my honor to welcome all the participants for this online webinar. My warm words of welcome then extend to our honorable guest for having readily accepted to grace us with his presence and words. I heartily welcome you, sir. On the same note, I would like to place on record my hearty welcome to our principal ma'am, Dr. K. Sivashankari ma'am. I welcome you, ma'am. My amiable welcome extends to head of various departments and staff members of our institutions. I welcome you all. I extend my communal welcome to our most beloved student, without whom the function would not be successful. I heartily welcome you all. I would like to conclude by thanking the organization and the members of this webinar whom the program could not have taken place. I hope that this session will be successful, enlightening and enjoyable to all the participants. I welcome you all once again. Thank you.
Thank you, ma'am. The peak of every activity is to enrich us with knowledge and experience. And now we are in the fun moment of listening to such experienced personality. I request Professor M. Lokeshwari, ma'am, Assistant Professor of Chemistry, to introduce our chief guest to the audience.
Good afternoon, everybody. My pleasure to welcome everyone to the national level seminar. And it's my great pleasure for me, sir, to introduce myself. Okay. Good afternoon. So it is my great pleasure for me to introduce our guest, Dr. W.B. Karnool, Professor, Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur, is a man of determination, dedicated and competitive driven individual with a versatile track record. He obtained his PhD in 2000 on polymer chemistry from RTM Nagpur University, Nagpur, and he presently working as a professor in Department of Chemistry, Kamala Nehru Mahavidyalaya, Nagpur. He published more than 200 research papers in national and international reviewed journals and presented more than 110 research papers in national and international conferences. He is also the reviewer of 38 international journal of Elsewhere, John Wiley, Springer, and RSC publishers, having impact factor more than 2. He has received CRSI Best Teacher Award for outstanding contribution in polymer materials presented by Chemical Research Society of India, Bangalore, at CRSI Symposium at Bhubaneswar in 2011. He is received Distinguished Scientist Award 2016 for their contribution in research work at Chennai by Center of Advanced Research in Chennai, and received the Oxbow International Outstanding Researcher Award in 2016 by ACS Publications Salem. He has also received a Best Researcher Award by Vishwashanti Society at MDI Singapore in 2017. His academic achievement includes Best Research Paper Presentation Award for 7 research papers in conferences. He has published more than 360 science articles in daily newspapers. The people of society aim to popularize the science. He has successfully guided 21 MPhil and 26 PhD students, and currently 8 students registered for PhD. He has successfully completed 3 UGC granted research projects of rupees 46,000, 46 lakhs 870 rupees. He is also an author of 42 books and 11 books chapters, 7 of which are internationally published by Apple Academic Press, Canada, elsewhere. He is the Secretary of Society for Promotion of Material Science, Nagpur. He is the Secretary of West Zone of Association of Chemistry Teacher, Mumbai, and a life member of more than 12 various academic societies. He is recently honored the Best Researcher Award by Rajasthan Tugdochi Magaraj University and ISCAS prestigious Silver Medal Award received in 11th ISCAS National Conference at Nagpur. He has delivered more than 50 invited talks in national and international conferences. He has organized 7 national and 11 international conferences for the researcher of India and abroad. He has achieved all his success in spite of all hurdles that came across the way. I am happy that he is here to grace our occasion. I once again welcome you back to this session, to one and all. So I welcome you, sir, for the session. We are all waiting for your interesting webinar. Thank you, sir.
Thank you, ma'am. All are made new and everything becomes scared through the presence of great personalities. Such a personality is here to fill our spirit with vigor and enthusiasm to his enthralling speech. Requesting our guest, Dr. W.B. Grunel, to address the students. Sir, please.
Okay, thank you for introduction, madam. So first of all, I thanks. Am I audible?
Yes, sir.
Okay. So first of all, I thanks the organizer, principal of the college, and Dr. Lokeshwari madam for inviting me for this national webinar. Before going to start, I'm sharing the screen. Okay, is the screen visible? Hello, is the screen visible?
Yes, sir.
It's
Yes, sir.
visible.
Yes, sir. It is visible.
Okay. So today's topic of this lecture is the advanced multifunctional materials and particularly the nanomaterials. So as we know, today we are in a dynamic world where the time domains and the geography are rapidly shrinking, but at the same time, space and opportunities are expanding with the competition as the key drivers. As we know, our economy, we are in a knowledge-driven economy, and this economy is related to the link with the science and technology. As we know, science and technology are complementary with each other, but they are different. So we can say that science is the pursuit of knowledge and understanding for its own sake, and technology is the creation of artifacts and the system to meet the pupil needs or the requirement of the pupils. And in the science and technology, chemistry is the main subject related to the societal needs. So we can say that it is the central science. It provides fundamental understanding needed for the societal needs, including many things that determine the quality of the life and our economic strength. And therefore, we can say that the development of many technology that make our life comfortable is closely related to the materials. So here we are discussing here the multifunctional materials, and there is a special branch or discipline related to the material, which is known as the material science. And there exists a relationship between structure and the properties of that materials. As we know, chemists invent and synthesize the molecules. Physicists characterize the molecule, and biologists make use of these molecules, and engineer fabricate devices out of this molecule, and public enjoy the molecule in different forms. So this is about the science and technology. Therefore, we can say that material engineering is the one of the branch is there, and in which they are giving designing the material, are giving the shape to the material as per the societal needs or society need for the pupils. So we can say that science and technology solve problems in order to understand the natural world. Or we can also say that science and technology solve the problems in order to improve the lives of people. And also we can say that science and technology try to find out the causes of diseases and try to find out the cure for this from these diseases. And therefore we can say that these material are material science, and material scientists play a very important role in the development of the country. As now we know that day by day there is a development in the materials and development in the technology. Material scientists claim that 21st century is the century of material and especially the nanomaterials. And in this first topic, we should have to know what is the historical perspective of these materials. So as we know, in the early days, Stone Age was there, then Bronze, then Iron, and now we are in a age of advanced materials. And this advanced material is nothing but the nanomaterials. So here, one can ask the question, what is the material science and engineering? So we can say that because of the advancement in the science, structural property correlation of this material, so a new discipline of science, which is known as the material science, is emerged out, which this with the study of this advanced material. And now, whenever we are discussing regarding the materials, there are four important pillars, we can say that, and four important parts are the processing, then structure, then properties, and what is the performance. So in case of processing, we have to synthesize the new material. So this is the first part by using different methods. After that, we should have to know the structure, second important part, in which we should have to know what is the arrangement of the particles, what is the subatomic particles, whether it is microscopic or macroscopic. So we should have to know the structure after synthesis is the second important pillar. After that, third important part is the we should after synthesis, after knowing the structure, what are the properties? The properties related to mechanical properties, electrical, thermal, magnetic, optical, and some other properties. So we should have to know what are the properties. And fourth important point is the performance. So we have synthesized, but what is the purpose? So we should have to know what is the performance of that material. So we should have to know what is the use of this material, what is the application of this material synthesized. So these are the four important parts in case of the material. And here is the characterization. So here is shown in the center what is after all these four pillars, what is now the important part after synthesis, that is the we should have to know the synthesis of the after synthesis the use of this, and after that what is the characterization of these materials. So this is the important part in case of the materials. And now we can say that perhaps those who control the material, then he control the technology. So once we control the material, we have a command on the materials, then it is possible to do some, we have some control on the technology. So whatever the needs, we can make the material, and also after that we can design it for the by using new technology. And therefore this is the important part in case of material science. Now in case of industrial revolution related to the materials, last 2 centuries shown that there are number of changes and technology developed day by day and showing some industrial revolutions. And this slide shows as the time progress, what is the changes taking place. So in after the Middle Age, steam engine came, is a big step. Then after that, railways, and then automobiles. And what is now next was the computer came. And now we can say that after this computer, what is the next step? So we can say that the next big step is the nanotechnology. So this is the important and useful branch which is useful to this society. So whenever we are discussing with the nanomaterial, we should have to know what is the nanotechnology. So here, this graph shows how the development of materials in the nanotechnology is there is shown. So here on the x-axis is shown the years, and what is the progress are shown on this axis. So in the early days, 1970, there was a basic research was there. Nanomaterial was there at the time, but majority was the basic research. After that, day by day, there is a development in the technology and the materials. What is then applied research came in around 2000, and then after that, again now there is a modifications, and what is now the scientists are saying that, and also we know that after 2020 there is a mass market of this material. So this is the graph shows how there is a development in the materials science. And now one scientist, that is the Professor Robert Kerr, he has given the talk in the IICT Hyderabad when he delivered a talk on the contribution of elemental carbon to the development of nanoscience and technology. He says that he got a Nobel Prize for that work, and he says that carbon nanotechnology was much more older as compared to the carbon nanoscience. And also he got a Nobel Prize for this also, and for the discovery of fullerene along with the Richard Smalley and the Harold Perto. So he says that carbon nanotechnology was much more older as compared to the carbon nanoscience. And also they have been estimated and also carried out many experiments and shows that the Damascus sword, that is the sword of Tipu Sultan or sword of Maharana Pratap or Shivaji Maharaj, that sword also contain large number of carbon nanotubes. So we can say that it is not the new technology, but we can say that it is the much more older as compared to the recent time. So here one example also given that nanotechnology was in ancient time, and it is observed that glass material of the Roman time shows that some coating of nanomaterials, and they scientists also suggested that the glass which was covered with the nanoparticles of the gold and silver, and which is also shown here. One example that nanotechnology is not a new, it is an ancient times. In ancient time also the nanomaterial was there, and this is the Lacquer's cup in the British Museum, which is kept in this museum, and this is the Roman pottery after Christ, and shows red color is nothing but the nano size gold. Here is just shown, and what is this is in a daylight, and this is the light emitted, and this paper was already published in the Nature in 2000. So from this we can say that so nano gold, nano silver was there in the ancient time, but people does not know how to use, whether it is a nano size. And the next slide shows so what are the different here, that is the when here I'm discussing the nanoparticles. So in that we should have to know what is the introductory part of this nano, what are the methods of synthesis, then what are the different methods of characterization, what are the applications of these, but at the same time we should have to know what are the properties and toxicity. Toxicity is very important, and what are the types. So what is nanomaterial? So we can say that nano size, all of we know, and student now generally knows what is nano. So word nano means, it is taken from the Greek word nanos, means dwarf. Meaning is, it is the prefix used to describe the 1/1000th of something. So 10 to the power minus 9 is the nano. So student also know what is the nano size. All of you know what is picometer, nanometer, micrometer. So 10 to the power minus 9 is the nano size. So, and we can represent, and also we can convert from meter to 1/1000 meter means 10 to the power minus 3 meter, and it equals to the 1 millimeter. So this is the conversion, and 10 to the power minus 9 meter equals to 1 nanometer. So this is the conversion, and this is the scale shown here. centimeter, millimeter, and micrometer, and also in nanometer. To represent this nano size, so we can write here 0.000000001 meter. So 1 nanometer equals to 0.10 to minus 9 or 0.00 meter. And also it is observed that 1 billionth of the meter is 1 nanometer. 1 billionth of meter is a 1 nanometer, and 1 nanometer is approximately 6 carbon atom wide. It is also observed that hydrogen atom is a 0.1 nanometer, and our humanoid is a 1.7 billion nanometer. So this is an interesting part, that nanoscience and nanotechnology is very, very important discipline. And so one can ask the question, what is the nanoscience? So particle less than 100 nanometer in diameter are said to be a nanomaterial, and study of such type of material is known as the nanoscience. And related to this, there is a technology which is known as nanotechnology, and it designs the materials as per the people needs. They are giving shape and size, and related to that as per the need. So this is the technology which is known as the nanotechnology. So this nano scale or nanotechnology have an interdisciplinary science, because we can say that this is not only related to this one field of science, it is integrated, or it is related to the chemistry, physics, biology, medical science, computer science, earth science, and also in engineering. What is the material engineering? So we can say that it is an interdisciplinary science and related to all these field or branches. So here the important part is of this nanomaterial. This slide shows how different field where we can use this material. So in industry, what are the branches where we can use reinforced plastic, catalysis, or construction purpose. Now nano size cement is also there. We can introduce the nano size material in the cement. It increases the efficiency. So in industries, number of industries are there. And also in case of food agriculture, for packaging, for pesticide, for improving the texture, these materials are very useful. In case of the environmental, for the wastewater treatment, or for making the biodegradable polymers, and for monitoring the pollution, for all these field we use this material. And in the medical field, it is very, very important, because nowadays in this material are using as for the drug delivery, and this is another important application in medical field. So what is now nanotechnology also have many branches, many field where we can use this technology. For example, is shown in this, in case of biotechnology, for transportation, for nature scrutiny defense, or in defense field, food and agriculture, medicine, aerospace, everywhere we find the use of this technology, and also in the aerospace. So these are the slide show. This slide show the way part or the field where this technology can be very useful. And now, what is nano? As we know, nano is small, and small is always powerful. And as we know, small is sustainable, and also we can say that small is for excellent performance, and we can say that therefore small rules large, and therefore small is beautiful. So nano is small, so it is very beautiful material, and because of that, now day by day technology are more, there is a new technology are coming day by day. Now here, this nanoscience or nanotechnology have revolutionary potential, but at the same time we should have to know about the environmental issues, some ethical and legal and social issues. It is very important when we deal with this material and this approach. Therefore, nationally or internationally, there should be some societies to discuss regarding this material, because we cannot when we are working with this material, if we inhale, then shows the dangerous effect, and because of it nano we cannot see that material, and therefore whenever we are working with this material, then we should have to discuss some issues regarding this. So yeah, at national or international level, the issues related to environmental and health, we should have to discuss. And as we know, in the R&D department of the industry, the industrial there are the infrastructure is needed. For infrastructure along with the human resources is also very important, and then they making some experiment and showing some industrial innovations. But at the same time, there are some societal issues like health, safety, environmental. So it can cause death also if we inhale the nano-sized particles. So we should have to take the care, and we should have to, there should be some discussion regarding this type of material or the field. So here, these are the two great scientists. One is a Richard Feynman, and he has given the approach of synthesis of nanomaterial. One is a top-down approach, top-down. And this Richard Feynman also received a Nobel Prize for his work, fundamental work in quantum electrodynamics. Actually, Richard Feynman is a physicist, and he has developed and suggested this top-down approach. And in this approach, we have to start from the bulk material. We have to cut that into smaller particle, and then after that we get the nanostructured material or nano-sized material. Another important approach, second approach, was given by Jean-Marie Lehn. He is a French chemist. He also received a Nobel Prize in chemistry in 1987 for the development and use of molecule with structure-specific interaction of high selectivity. And he has suggested the bottom-up approach, shown here, bottom-up approach. So bottom-up means we have to start from atom and atom, molecules and molecule, cluster and cluster, so that we get the nano-sized material or sheet. Now, important part is that what is meant by top-down and what is meant by bottom-up. So they also suggested that in case of top-down model, the Feynman says that there are plenty of room at the bottom. And Marie then says that there are plenty of room at the top. Plenty of room means there are plenty of room at the bottom, there are plenty of room at the top. It means that suppose, I'm giving an example, suppose one room is there, that room can be divided into a two part by dividing, making some compartment here, dividing into two part. Again, it is possible to make it in a make a partition, and what is we can make a four part. So again, the one part cannot also be divided into four in this way. So number of parts we can make in case of this nano size. Even it is nanomaterial or it is in a nano size, even there is a more capacity of storage and having more, it is possible to make the more compartment. Even it is a small particle. And therefore we can say that there are plenty of room at the bottom. We can make as we like the compartment, and we can store the material, we can use that part. So therefore they are saying that there are plenty of room at the bottom and there are plenty of room at the top. So these two approaches, top down and bottom up, is very, very important to synthesize the material. Now, one can also ask the question, why do we want to make the thing small? So we can say that we make a thing small because it should be cheaper, smaller, faster, and better, and easy to handle, and easy to carry, and use in a different purposes. And that is why we need, we want the thing small. As we have seen, small is a beautiful, and therefore we want to carry easily to from one place to other. So we want things small, as we have seen. And also there is a new phenomenon of science and technology. And so as we know, if small thing is there, then it is better. We can carry from one place to other. Now also in future, our complete network or this our pen will contain in a future will contain all laptop and all the internet and all this facility. The whole world can come in that pen. Now uh, the work is started on that part. So the things, if it is small, in this case, if the it depends upon the materials. And also we have seen that day by day storage capacity of the laptop or the mobile phones are day by day increases. It is because of these newly synthesized materials. They have more capacity of storage. Now silicon chip is replaced by another nano size chip, and so many applications of these materials are there. Now here we can say that nanomaterial is an important part here, and when we deal with this, we should have to know some properties of the material, and therefore with the change of structure, there are changes in the different chemical and physical properties. If we change the structure, then the chemical and physical properties of that material changes, and depending upon the size of that material. So size of the materials is very important, because size, so many properties are there which are the depends on the size of the materials or particles. In case of small material, in which the strong chemical bonding agent, where delocalization of electrons are extensive and extent of delocalization vary with the size, and because of that, this uh, the size is very important in case of material, and that is why nano size is very important. So nano size means they have number of properties, and they can perform as depending upon the size of that material. So size is very important in this case. Now one example is shown here in this slide. Change in the properties of nano resin show changes in the different properties. So three approaches are being shown here. This is quantum mechanical behavior. In this case, there is a changes in the color, transparency, hardness, magnetism, and electrical conductivity. Second approach shows that if increase in the surface area, then we found some new chemical processes where they show the changes in melting and boiling point, chemical reactivity, catalytic yield of that material. And third approach is shown here, molecular recognition. So we can say that this is the new bio applications, and because of that, there is a recognition, adaptability, repairability, self-organizations, and here is shown that this drug or any nanoscience drug can be injected in the body and can repair the infected part. So these are the three different approaches in case of the nano resin. Now, here is shown there are 7 properties. All these 7 properties show the changes in this as the size change. So we can say that this property depends on the size of the particles or size of the material. So here is shown this slide. Nano sizing causes the changes in color. As we all know that gold, bulk gold is a golden in color. This is the bulk gold having the melting point 1064, and gold color is the golden. But when the same gold, when the size changes, they show the changes in color. So in this case, here is shown. See the smaller size of particles, and in this case, color is brown or yellow. In case of second, red, color gold. Here, purple or violet color, pink color gold, purple colored. In this is smaller size, slightly greater size, and again somewhat greater size. So here, when the size of gold is 1 nanometer, shows yellow color. When it is a 20 nanometer, show red color. When 100 nanometer, show the purple or pink color. So these are as the size changes, they show the change in color, and some melting and boiling point also they show the changes. So we can say that the properties depends on the particle size. This is another example that indium phosphorus nanoparticle, cadmium selenium shows here in this case, see the solution of this cadmium selenium in solution when the particle size is 4 nanometer, 4.2, 4.8, 5.5 nanometer of this solution. So see the color shade changes from light green, then yellowish, and then orange. So as the size changes in the nanomaterial, they show the change in color. Now also it is observed that nanosizing also changes the chemistry. And now see the size. This is the gold oxide. This is the nano size, and this is the larger size particle. When such type of particle larger size then emit only the carbon monoxide, but when it is a smaller size, it emit the carbon monoxide as well as carbon dioxide. So we can say that our great scientist C.N.R. Rao have been shown experimentally, and this paper have been published in European Journal in 2002. So what is now, as the size changes, the chemistry also changes. So nano sizing changes the chemistry, shown in this. This is an example. As we have seen, top-down and bottom-up approach given by two scientists, synthesis of nanomaterial. So first part here, we are going to discuss what are the methods to synthesize this nanomaterial. Top-down is one of the approach, and second is the bottom-up is second another approach. So in here is shown diagrammatically. Start from bulk, slash it or cut it, this bulk material into smaller so that we can get the nanos particles. And from bottom up, start from the atom, smaller particle, atom to atom or small molecule to molecule, wave to or cluster to cluster, and we get the here these small atoms and atom interact and we get cluster, and from this we get nanoparticles. So these two approaches are mainly used to synthesize the nanomaterial, top down and bottom up methods. Now in addition to that, two models have been given, top down and bottom up, but in addition to that, green method approach is also there for the synthesis or for the preparation of metal nanoparticles. And in this case, metal nanoparticle, here we have to do the reduction. First of all, we have to take the plant extract and then reduce it by using sodium borohydride. So this is the green approach for the synthesis of nanoparticle. Gold nanoparticle, silver nanoparticle, lead nanoparticles, some other nanoparticles may be present. And these are the trees, plant, where these are the medicinal plant, neem or aloe vera, all these are the plants. We have to take the leaves, abstract of the leaves, and then these are the example, and one example is shown by using the extract by Soxless extractor. Take the extract and reduce it by using different methods. So that one is also one of the important approach for the synthesis of nano particles or nanomaterial. We can say that it is the green approach for the synthesis of this material. And so we can say that these are, for example, we have synthesized silver nanoparticle by using a neem trees, leaves, extract, and silver. First of all, take the neem extract, which contain terpenoid and the flavonoids, and we have to use sodium borohydride as a reducing agent. And here, these are some other methods shown here. Methods for the preparation, chemical, sonochemical, and different methods have been shown for the synthesis of nanomaterials. And in addition to that, some more methods have been given here. More modern methods have been given here. And by using these nano size particles, these are here 13 different models have been shown. And these are very important. We can generally sol gel methods are used for the synthesis of these nanomaterials. Chemical precipitation, hydrothermal method can also be used. So any one method we can take here, but generally sol gel methods, hydrothermal, chemical, and some other methods, laser pyrolysis can also be used. So by using any one methods, all the methods details are given already in the literature, or we can say that on the internet. You can search the method and also use for the synthesis of nanomaterial. Some methods I'm giving here. One is a sol gel process for the synthesis of nanomaterial. Metal oxide nanosize can be synthesized by using this method, sol gel. And here is shown in the slide. There are 7 stages. First of all, we have to mix the starting, then casting, gelation, aging, drying, stabilization, and densification. So step by step. So first of all, we have to mix the component of that for the synthesis of that material. Sol is and gel is formed, then mix it and then age and dry. So step by step, what is the 7 stages of shown, and finally here we get the dense gel, which is the product of this method. As we know what is sol gel process, so this process is a wet chemical technique used for the fabrication of both glassy and ceramic material. And in this process, use of either chemical solution, we can also say sol solution, and or colloidal particle, that is the particles to form the network that is called gel. And after drying process, the liquid phase is removed from the gel. This method was strongly used for the synthesis of nanomaterial, and in this case, sol is liquid of colloidal solution, and gel is can be described as a solid or semi-solid. In this sol gel, sol can be converted into gel by cooling, or gel can be converted into sol by heating. So this is the one method of synthesis of nanoparticles. Another solothermal method is a very important method, and in this method is a typical wet chemical synthesis method using water or organic solvent as a reaction medium. In a sealed vessel, generally the reaction is carried out in autoclave. And we have to maintain the temperature between 100 to 240 degrees Celsius. This method is a better as compared to other method. And precursor can be used, in this case is a non-aqueous, generally non-aqueous. So the process is carried out in an autoclave. So solothermal process is also good method as compared to other. One more method is there, hydrothermal method. Hydrothermal method generally also used in an autoclave is required, and in this method includes different techniques of crystallizing substances from high temperature aqueous solution to the high vapor pressure. We have to maintain pressure and temperature. This method is used to synthesize single crystal that depends on the solubility of the minerals in hot water under high pressure. The temperature is maintained in this case, in this method, and up to 300 degrees Celsius we have to maintain the temperature in case of hydrothermal method. So these are the 3 different methods shown here, and we can also synthesize different nanoparticle by using different method, and also we can see the morphology of that. Is there any changes? In addition to that, now this is another method, what is known as the slow combustion. Here is this is the lamp shown here, and when we keep this lamp for the longer time, for 1 month or 2 months, then here on the wall, on the top here, the there is a this carbon black is there, and when we analyze this is the nano size. So this carbon black is collected. So this is the slow combustion. We have to fix the flame in this way. So what is now, because of this, there is a because of what is now not complete combustion, uncombustion. What is this carbon get collected here on the wall of this window like that here, and this when we analyze, it is observed that it is found in a nano size. So nano material can be synthesized by using also slow combustion process. This is the morphology in case of one figure is being shown here. As we change the solvent, also show the changes in the nature or morphology of that material. And tungustic oxide shows, see here in pure ethanol, in mixed solvent, and here in a pure water. So see the nature, or we can say morphology, are different of the same compound. And after synthesis by using different methods, there are some methods to characterize the nanoparticle. So first method is the same scanning electron microscopy. Then 10. So here is shown scanning electron microscopy. In this case, the arrangement is shown how to make the arrangement. So in case of same, what is now here, sample you have to put, and now then electron beam we have to pass from this, and electron gun is here. With the help of this electron beam is passing, and then here is a magnetic lens. After passing through that, then what is now, here is a scanning coil, and shows this type of arrangement, and here is the final stage. After scanning this sample, what is now here, it is connected to the TV scanner. So electron microscope, this electron microscope shows the image within 2 minutes, required only 1 or 2 minutes to take the image of this. So it gives the image, and from the image we know what is the nature and what is the morphology on the surface of the material. So generally this morphology, whether it is different types of morphology we get depending upon the material, and the same give the surface morphology. But now if we want the complete morphology of the material, then we have to use the TEM, transmission electron microscopy. It gives the complete information about the whole body of the material. That is the that beam here scan complete outer side as well as in the bulk also. What is the particle size, what is the nature, morphology can be known by using transmission electron microscopy. So whenever we are discussing with the nanomaterial, these two are the important methods to know the size. One more important method is the AFM, atomic force magnetometer, and again this is the accurate and important method, and arrangement is shown here. This is the surface of the material, metal oxide or nano size material. This yellow color is shown, and this is the AFM where there is a one tip. We have to touch this tip at the particular part, then it gives digitally what is the particle size of that material. If you touch this here also, it is possible to know the size. So at particular point on the surface, you have to touch this point and we know the particle size of that material. The reaction is shown. This is the surface atoms. When we apply force, what is now? These are the tip atoms shown here in this way. And because of that, it is possible with the help of this magnetometer AFM, we should have to know the, it is possible to know the particle size. Another method to know the particle size is the X-ray diffraction. So all these are the methods to know the characterization, what is the particle size, and also what are the arrangement of the atoms. So detail about the XRD, give the detail about whether the angle and the bond length, all these details obtained from the XRD. So here is a graph is shown, which is known as, this is the equation, Cherry formula. He is a scientist, he has given this and all the terms have been given here, and with the help of it, we should have to know what is B and theta and put this value P and theta here. It is possible to know the details, what is the thickness of that material, what is the particle size of that material. With the help of this X-ray, it is also possible to know the particle size and other parameters. Now there is a carbon nanotubes. Again, now another part is there. When we discuss the nanomaterial, then we should have to know what is the nanotubes, which is known as a CNT. So this is the important part in this case. And as we know, carbon is in an allotropic forms. So the slide show different allotropic forms of the carbon: diamond, graphite, as we know, fullerene of C60, C70, C80. And here is a graphene now. Network sheet is shown, which contain only the carbon. This is the allotropes of graphene. Is also now graphene oxide also shows this type of nature. So this is the graphene sheet, three-dimensional network is allotrope. And one more is there, what is now CNT, what is carbon nanotube shown here. This is the carbon nanotube where it contains only the carbon, but the CNT can be synthesized by the particular methods are there to synthesize the CNT, and CNT have much more applications as compared to simple material. Here is a single walled CNT and the multi-walled CNTs are there. First figure is a single walled and second one is a multi-walled carbon nanotubes. So single walled is a allotropes of carbon. Structure can be cylindrical tube-like. Cylindrical tube may have one or both the ends capped with the hemisphere of buckyballs. So this is the first one is the single walled carbon nanotube, and second here is shown in different colors. This is known as the multi-walled, and these multi-walled carbon nanotubes are special form of carbon nanotubes in which the multiple single walled carbon nanotubes are rested inside one another. So see, one by one the sheets have been placed there. So two types of carbon nanotubes are there, single walled and the multi-walled. And these are CNTs can be synthesized and different methods have been given for that. So we are discussing also some methods are given shown here, and this slide show what are the different types of carbon nanotubes. It is observed that three different types of carbon nanotubes have been shown, and here is an armchair. This is the arrangement and structure. This is the zigzag type, and third one is the chiral type. So three different types are there, three basic types are there of carbon nanotubes. That is the armchair and the zigzag and the chiral. So now on this we can also introduce some other groups, but mainly the three basic types of CNTs are there. And as we know here that now the synthesis are there, and as we know carbon nanotubes are cylindrical molecules which contain the rolled up the sheet of the single layer of the carbon atoms, which are also known as the graphene, and it is noted that CNTs are chemically bonded with sp2 bonds. So CNT is very important. Related, this is related to the carbon nano, or we can say the nanotechnology. And three important methods are there to synthesize the CNTs. One is the electric arc discharge method. Second is the CVD method, and laser ablation method. So this, out of that, we are using this CVD method, that is known as the chemical vapor deposition method, and laser ablation method. I have one of my friend, that is the Professor Pankaj Koinkar, is from Japan. They are synthesizing CNT by using laser ablation method. So here the CVD method consists of this type of arrangement, and in this case our reservoir shown here, and in this reservoir is nothing but the solution of ferrocene dissolved in the benzene, and through this outlet, what is carrier gas, we have to argon, we have to pass, and here is a thermocouple of K type, and this CVD method is the most widely used method for carbon nanotube synthesis. For this purpose, the metal nanoparticles are mixed with the catalyst support such as magnesium oxide or aluminum oxide to increase the surface area for higher yield of the catalytic reaction of this carbon feedstock with metal particle. And the precursor, the procedure of this CVD method can be optimized to obtain uniform layer of the CNTs on the substrate. And after making all this, and here is shown also solution of flow rate is shown 3 ml per minute. Carrier gas, we have to use argon, and atmospheric we can use inert or sometime air. After making all these arrangement and solutions, what is then next? Solution from the reservoir comes here, and because of this K type of thermocouple, what is they interact, and we obtain by using this type of CVD method, what is we obtain the CNTs by using this method. So solution strike that the thermocouple, and we get the particle. In this case, that's particle generally observed, it is a carbon nanotubes. These CNTs have a lot of applications in our daily life and also in some field. So this is the carbon nanotube, and observe that it is also possible to make the nanocomposite, can be used as a film, used in a biotechnology, used for the energy storage, as a biosensor, or as a fuel cell, in for environmental purpose, for purification and some other, for packaging. So number of applications are there of this nano size carbon nanotubes. Now it is observed that carbon nanotubes are being used to develop the flat screen television. Nowadays, these CNTs are using to make television screen or PC screen, and our next screen, that is TV screen, may be very thin, ultralight, and can be foldable. So our next TV we can carry easily from one place to other because it may be a foldable. And here is shown the PC can be folded, and there because of folding, it takes a lightweight also, and it takes a small space. So very easy to transport from one place to other. So now work is going on this part. So these carbon nanotubes are very useful. Now it is also observed that our scientists at MIT of USA, they developed the biggest computer chip using CNTs. And instead of silicon, they are using the CNT. And because of that, they also have been published the paper in Nature in 2019. So here is shown the biggest chip of CNT now using in place of silicon chips. This material, we can say CNTs, can be useful in the badminton, here tennis ball racket, and also in the bicycle. The whole body, this is the modern size bicycle, and here the body is made up of the CNT, and because of CNT is not heavy, it is because of made up of CNT. What is this bicycle is very lightweight, but again strong as compared to other material. And here is also, this is the body of this tennis racket. It made with the carbon nanotubes, CNTs. The material can be used for making such type of rackets. And purpose is made of this material. But is now the racket is or this bicycle is very lightweight and also strong. And now one more application of this material is there. These fabrics of nano size of CNT can be very, very useful to the military person or soldiers. And because of that, this material can manipulate the light and make the soldier invisible, may come in this way. Some sensors can also be made in that, and therefore they can give the conditions and locations of that part. And also radio communication waves directly into the uniform fabrics can be passed easily, and because of that, chemical and biological protection is there for soldier. So if there is any biological or chemical effect or nearby, there is a shown in that field, then what is now the soldier get protection from such type of biological or because of that microorganism. If they throw that, what is now he get the protection, and also if there is any chemical war, in that case also he get the protection. So this is a useful material. CNTs are very useful to the soldiers. Now some properties we should have to know about the nano size materials. And in case of mechanical properties, we have observed that there is if we introduce some nano size material in the polymer matrix or in some material, what is then they show the enhancement in the mechanical properties. So we have been observed, it has been observed that the material obtained after using this nano size material, it is stiff as diamond. Young modules, tensile strength, electrical property increases with the increase of that content of that nano size particle, and also show some metallic SO and semiconducting properties. And also there is an enhancement in the thermal conductivity. Because of that, these CNTs, we can introduce any group now. Here is shown some examples of shown. If you react with this nitric acid, heat it, so nitro group can attach. If you take the carboxylic acid or the amines or alcohol, they get introduced in the carbon. Because it reacts with the carbon, we can introduce new in the carbon, because this CNT is nothing but the carbon. Everywhere we find carbon, and we can react, or we can attach, we can introduce some groups in that. So when we attach some groups in that CNT, they show some change of behavior, change of properties have been observed. Now, some applications have been shown here. Application of carbon nanotubes. Nowadays, this material can be used to develop the flat screen of higher resolutions. And our next TV screen should be, will be ultralight or foldable. Badminton racket, tennis racket can be incorporated with the carbon nanotubes. Use of this material improve the efficiency. Even this material can also be used in a square in the cities for the signaling. Three signals are there, yellow, red, and green. So for making that also, nowadays the government have also started working on this, and this material CNTs are using in majority of the cities for the signaling in the square. And it is also observed that the addition of some nano size or CNTs in the cement, also in Portland cement, there is an increase in a 30% efficiency of that material or cement. Here is the graph shows this picture. Now this morphology is shown, absence of CNT. What is the nature? See now here, sticky material. And after that, what is the presence of single walled? What is now again, now it very compact. So gaps are now less. And when we use multi-walled, what is now, see the nature, very sticky and very close and very strong bonding. So this type of three different figures are being shown. And it is also observed that when we mix multi-walled with the cement paste, what is the strength and efficiency of the cement increases by 30%. And if you use single walled, what is then slight increase is there, not much more. But as compared to plain cement, we can increase the efficiency of that in terms of strength and durability of that. So what is now, this is one of the experiment which is shown here, that it increases the efficiency by addition of CNT. Now this is one important compound, what is known as the Nano Gold. We have seen Nano Gold, when we change the size, it shows the change in the properties and also especially the color. And carbon is the wonderful material, but in addition to that, gold is also, Nano Gold is a very versatile material because they show some interesting properties when it is in a nano size. And the properties of this gold shown here, this nano gold can be used as a catalytic material. When it is, because of the smaller size of this, the surface area of these particles are become very large. And because of larger surface area, it is a very good catalytic, it is having good catalytic power, and therefore it is a excellent catalyst for some reactions. And here is shown one more property. As we know, size changes, color changes, properties also changes, and also show the changes. And here nano gold can be used as a catalyst. But in addition to that also, as the size changes, the size and shape also show the change. When it is a nano size, or when it is a bulk, then what is the nano gold have face center cubic structure. But when it is in a nano size, when the nano gold have a icosahedral structure. So both the structure shown here in this slide. So as the size changes, structure also show the change. This nano gold can be used as a catalyst because of the smaller particles and larger particles, and because of that larger surface area, larger the surface area, better the catalyst. And here is shown carbon monoxide oxidation at temperature of low as minus 70 degrees Celsius. For this case, this nano gold can be used as a catalyst. Nano gold can also be used as a catalyst in the partial oxidation reaction. For example, propylene to propylene oxide. At this temperature, catalyst can be used as a catalyst. In some other process, nano gold used as a catalyst in the recent year, and it used as a catalyst in chemical processing, pollution control, and fuel cell applications. And now in the Japan, in Osaka National Research Laboratory, Japan, they have shown nano size gold particle can be used to prepare the odor eaters in the bathrooms. So now it is showing, we can say that a number of applications of this nano gold are there. One more important property of this nano gold is used in the medical field, that is in an angiogenic therapy. By using this nano size medicine, we have to inject, as shown here, single drug or multi drug can be injected to the infected part of the body of that. And after injecting, this is the single nanoparticle here loaded and multi drug loaded nanoparticles. So they after injection, what is now that nano size particle repair the infected part, and after it get digested because it is DNA based. It is also possible to inject the multiple drugs of different types for the repairing purpose in the, and so for drug delivery nowadays, this is the important therapy to remove or to repair the infected part in the body. So for this purpose, nano gold is very useful. As we know now here, another material, that is the silver nanoparticle. Similar to nano gold, nano silver is very important, and this nano silver can be synthesized by using different methods as we have discussed. And now here, a green approach is shown. Silver nitrate is obtained from the plant extract, for example, neem extract. Then we have to reduce by using the sodium borohydride. The reaction is shown here, forming silver, and the hydrogen gas is evolved and forming diborane here and NaNO3. So this is the green synthesis of silver nanoparticle from the neem extract, which contain the terpenoid and flavonols as a reducing agent. So here, silver nitrate solutions obtained. After that, from this we prepare this nano silver nanoparticle of silver, and here is shown different shades of this silver nitrate from which we can extract the silver nanoparticle. So different colors are there depending upon the size of that particle. And this silver nanoparticle have number of application in the different field again. This silver nanoparticle can be used in as an antibacterial, antifungal, anti-tumor, antioxidative, biosensing, in imaging and textile, drug carrier, water treatment, or in cosmetic also. Nowadays we are using, and these are the area where this silver nanoparticle can be used. Now this silver nanoparticle nowadays also using in a washing machine, and some medicinal gloves or aprons embedded with this silver nanoparticle. As we know, the purpose of mixing this nano silver to sterilize it and to remove the bacteria and odor from that part, and therefore these silver nanoparticles and silver nano is using in this case. So here is shown cotton bundles here, and which is embedded with the silver nano silver. Here hand gloves, here is the apron embedded with the nano silver, and only the purpose is that to sterilize and to remove bacteria and the odor, bad odors. In the similar way, zinc oxide is an excellent material. It can be synthesized easily in the laboratory. So there is a question why zinc oxide is a much more interesting. The use of this material and zinc oxide is interesting because it is used in a medicinal field for cold, rashes, antiseptic, sunscreen, lotions. All these are made up and zinc oxide is the major component. This is also used in the manufacturing of the rubber as a rubber cure or filler. So zinc oxide also used in a rubber as a filler to enhance the properties of that rubber, natural rubber or synthetic rubber. Now pigment, it can also be used as a pigment for paint and coatings. And also it is used mainly in the laser diodes, LEDs and transparent thin film coating, and some piezoelectric properties are also there. And again now there is a bright feature of this material. It is because the direct band gap semiconductor can be replaced silicon as the main substrate in chip manufacturing, and also shows dual semiconductor and piezoelectric properties. Because of all this, now this material have some bright feature. If you want to synthesize zinc oxide nanostructure material, then zinc oxide, then what is here one method and chart is shown. First of all, we have to take the 1 gram of zinc powder of the highest purity in a alumina boat, and then insert preheated in a furnace and located in the center of the tube of the furnace. We have to keep it for the 900 degrees Celsius for 10 minutes. After that, zinc oxide material in the form of white cotton like structure get deposited on that alumina boat and silica tube. After that, we have to characterize. After once we get that material characterized by using XRD, by using SAME, by using TEM, and then after characterization, what is the purpose of this material? So this material can be used for the different purposes, and by using different method, we obtain different nature of this material. Zinc oxide have this type of different nature, morphology. So what is nanoparticle? Nanoparticle types, and this is the nano tetrapode site, nano flower types. This is the nanokite type, nanokite, nano rod type. See the rod like structure, nano star like, nano comb like, or wire. So in this way, we get different morphology of the same material by using different methods. So this is the morphology, surface morphology of zinc oxide material. So it is also very interesting and having bright feature. This zinc oxide nowadays using in a cosmetic material and particularly in a sunscreen. So large number of zinc particles are there, and nano size zinc oxide particles are also there. As we know, in the old days, in a cricket match, test match, what is players are using this type of sunscreen where large size zinc oxide was present. But because of that, when we use this on the outer part of the face, what is then look like a in this way. This is the traditional look like a spot, like a white spot here shown. This is the sunscreen where large size zinc oxide used in that. And now, so what is the use of these two different sizes? So large size zinc oxide block the UV light, protect from the sunlight, and scatter the visible light and appear white. So here is shown. But nowadays, nano size zinc oxide introduced in the sunscreen, and what is the function of that? So it block the UV light, and it is because of the smaller size as compared to the bulk zinc oxide. What is then visible light that day doesn't scatter it and appear clear, not this like a white. Here is shown one picture, and here zinc oxide in sunscreen using, and there is no any white spot. So zinc oxide nanoparticles looks like this. So this is very important material, zinc oxide. one experiment we have carried out and shown that this zinc oxide can also use as a supplement to the catfish. So in this catfish, what is here is shown. This is zinc oxide, red color nano size zinc oxide, and blue color show the control. So this is the control. By addition of simple here the zinc oxide only, what is how the increase is there we have observed, and here the after 1 week what is the weight of this catfish. So zinc oxide can be used as a feed for this, and it is observed that after 1 week, so there is a initial, this is the control. Then after few days, 0.2 gram increase, 0.4, then 0.8, 1.2, 1.6. So 1 week estimate have been carried out, and there is a enhancement in the weight of the catfish when we give the food of this type to the catfish. So after 7 weeks, it is observed that there is a much more gain in the weight of this catfish when we use nano size zinc oxide. In case of magnetic properties, we can say that this material have excellent magnetic properties, and because of that, it store large number of material, because again it is a smaller size, and now these chips have been replaced by silicon and other chips. So they are. It is also possible to make the nanocomposite of this material. So carbon nanomaterial or nanomaterials, non-polymer based metal ceramic can be made, or polymer based polymer ceramic, non-composite, inorganic organic hybrid, or bio non-polymer base and polymer base. We can mix, and purpose is that they show the unique physical, chemical, and optical, mechanical properties, electrical properties, and so nanocomposite can be mixing by by taking three component. Different types of composition are being shown here, and this composite have number of applications here. Different part of this car can be made by using this nanocomposite, and therefore this is the versatile material in the car. So shown here, what are the parts here, this part and this glass, and also fuels tank, and also nanocomposite. So this nanocomposite can be used for energy storage, solar cells, fire retardation, food packaging, biodegradable polymers, nanocomposite, water purification. So many applications of these nanocomposite materials are there. Now, we can say that this material can also be used as a superconductor, and because of superconductivity, we can say that here is this graph is shown between temperature in Kelvin versus resistance, and this is the part where this is the area where it is the material act as a semiconductor. Here is the metal, and after this critical temperature, what is now here, SM is same, is the semiconductors, or we can say superconductor here. So beyond this line, it behave as a superconductor. So metal, what is now insulator, then semiconductor, then metal, good conductor, and then superconductor. So we can say that superconductor is the material where physical properties observed in certain material, where electrical resistance vanish and magnetic flux field are expelled from the material. So here by using this property of nanomaterial, so here this clearly shows the graph. This is the line where critical temperature is there, and beyond that superconductor, below it behave as a metal and semiconductor. So this is the important part, and Meissner effect shown. Meissner have shown when T is greater than Tc, then lines of magnetic are passing through this material. But when T is less than Tc, When it is greater than, this type of behavior is observed. When it is less than Tc, what is the, it is not passing through the material but passing through the vacuum more. So we can say that superconductor expel all the magnetic flux from their interior, and therefore it force out of a magnetic field. And because of that, we can say that the superconductor can float, or we can say levitate above the magnetic field. Here is shown. This is the superconductor because of this superconductivity. So see here, superconductor can float. See here how, and here is the magnet. This is the magnetic field, and superconductor float. This superconductor is not touching above the magnetic field. There it is moving, float. See here, and by using this technology in Japan, the bulletproof train they have made, and the speed of that is a 500 per kilometer. So this is the train in Japan, frictionless train. We can say it is a frictionless train they made, which is known as a bulletproof. Also in India, from Gujarat to Mumbai, they have decided to make it. So the principle of this superconductor is shown here, showing the Meissner effect and how they float. So this is the train moving on the track of magnet field. So this is the magnet, but it is not touching on the, it float or levitate above this magnetic field, and because of that the speed is maintained and can also be controlled. So this is one of the application of this superconductive conductor. Another this important application of this material that can be used in a superconductor. It can also be used as a superconductor in taking MRI, and for this niobium titanium superconductor material can be used. And here is shown one application, that is MRI of the body can be taken in the presence of liquid helium. So for this purpose, niobium titanium superconducting material can be used. It takes the image. So there are benefits today and also tomorrow of this in a different field, medicine and health, and then for the drug delivery. We can also say information technology, and for energy production storage, material science and lightweight and strong, food, water and environmental, where we use radiation protection, and instrument and tunneling microscopy. So these material are beneficial today also and tomorrow. So these are the area where nanotechnology can be used, and different field have been shown here, the use of this nanotechnology. So now here one important application also is shown, and this is the LED, and this Thomas Edison was the first to introduce the incandescent bulb in 1880 and converted electricity into artificial light. So this artificial light, and now day by day different LEDs came out in the market of different materials, and here is shown a red emission of red or green or blue color, and these are the material for this purpose can be used as a LED material. In LED semiconductor diode, and when connected to the power source, current flows from the anode to the cathode. So here is shown what is the inside a light emitting diodes. So inside the diode, light emitting diodes are there, and known as the LED bulb. Now we can also compare candle, here bulb, CFL bulb, then LEDs are here shown. The mechanism of this is now different types of sources are there and bulbs are there, but now OLED is now recently developed, and OLED televisions also came in the market, and here these emit the light, and the material is shown. This is the organic material. So organic material are the emitter of different colors, and this red color here shown the material organic type, polymeric materials. What is this? Is the another metallic cathode, blue color, and here is the transparent and conductive anode is here. This is the sheet. Between cathode and anode, we have to place this material, organic material, and this is the substrate. From through this, now they show the emission of light. So OLED have such type of mechanism, and because of this OLED, it is better as compared to the LED because it show brighter, clear, thinner, and lighter in weight, and low powered. And it can also be printed on the various surfaces of the board. So this is about the OLED. And now one scientist in the USA also, he has made lithium powered heart. So we can say that it is the miracle of the science, cardiac pacemaker, and which is operated on the battery. And this is developed by the professor of chemistry, Robert West. And this is the device that effectively jumpstart broken nerves connection in condition like Parkinson's, epilepsy, and echotininus. So this lifespan for this initially 2 years, but now maybe up to 10 years. So this is the powered heart made by lithium, and the scientist is the Robert West. So we can say this is the miracle of this science and technology. Now, in addition to that, some applications are there of these nanomaterials or nanotechnology. Main three applications we are discussing here. First one is in the that is a material can be used as a technology for the healthcare and for environment. Four important applications shown here, and one by one. So here, first application of this is the material. We can say that it is the strain resistant cloth, where for this purpose nanofiber can be used, made of this nano size material, and fabric can also be made. And this is the colored stain which is on the surface of the cloth, and this is the stain can be removed easily when this nano size material introduced in the fabrics, or we can say nanofibers. Nano fabric, and these are the different color stain, and even if there is a dust on the cloth, it can be removed easily by pushing by just removing easily from the surface of that cloth. So this is one of the application that nanofiber created the cushion of air around the fabric, and because of that it is easily removed from the surface of the cloth. So now in the future there is a possibility of we can wear such type of cloth made up of by using the nanofibers, which are dust repellent, color repellent, and easily can be removed. There is no need of washing. So such type of material in the future may come in the market, and this is the beauty of material. Another is the nano paint, and it is the when we use nano paint on the car, it can also be used on the tall buildings. So now scientists have shown that this car when painted with the nano paint, then it is a water repellent, dirt repellent, resistant to chipping, scratches can be removed easily, show the brighter color, enhance the gloss, and in the future, scientist says that the color of the car can also be changed or self-repair. So nano paint made with this material are very useful, and such type of nano paint may come in the market soon in the in our market in our country. Scientists are working on that part. Another important application for environment to control the pollution, and here as we know, this is the tallest building in Dubai, which is known as the Burj Khalifa, where they have been already used the nano paint on the outer side. And as we know, what is when we use such type of nano paint on the surface outer side part of the tallest building, then it what is now it reduces the pollution. And as we know, when it is exposed to UV light, TiO2 present in the paint can break down the organic and also inorganic pollutant present in the air and wash out during the rain. And it also decomposes the formaldehyde which is present in the air. So all these pollutant can be removed easily by using this type of paint. And because of that, it protects the building from dirt, from any type of damage like that. So nano paint is very important material for surface of this type of buildings. In case of environment also, now uh, there are limited sources and we have to use carefully the electricity, and the alternative use for this is the nano solar cell. The technology have been developed already and so many papers have been published on this part. And nano solar cell, when we mix with the plastic, can be painted on the bus roof or roof of the house or roof of the train also. So mechanism is that this is the chip mixed with the nano solar cell mixed with this plastic, and this can be used. So mechanism of this is shown here. This is the electrode, this is the nano rod shown, and this is the glass. This is one electrode, this is another electrode, this dark color, and between there is a nano rods material, and sunlight when we pass, it passes through the glass and then through this nanomaterial of the 200 nanometer size. Then they make the energy which is known as solar energy and stored here. So it is possible through this this is the mechanism is shown here, and such type of chip can be made, and this chip can be made on the roof of the car, roof of the bus. So we can drive this bus or car through on the solar cell. So in future also such type of material may come in the market, nano solar cell, and therefore it can useful for the reduce the pollution and also to protect the environment. So instead of using electricity, nano solar cell can be used for automobiles, car, bus, train, or other vehicles. So here one more application is shown here, technology. That is, we know CD can store some part of the movie or some part of the material. DVD can store more part as compared to this CD, and silicon chips can store much more as compared to DVD. But now the silicon chip is replaced by 10 nanometer size. Nanometer, what is the nano size, nano material used in this chip and made, and because of that the silicon chip is replaced by the nano size chips material, and now we can say that the storage capacity increases day by day by using this type. And now nanomaterial used chip have much more larger storage capacity. We can say that 1 lakh times greater capacity as compared to the other silicon chip or other materials. So much when the chip is made up of this nano size material, then the much more storage capacity is there, and because of that day by day storage capacity of our electronic devices increases day by day. So this is because of this nano size chips using in that device. So these are the field where again this material can be useful in biomaterial, in the bone, teeth, cell, so many in medical field for drug delivery, diagnostics. Number of fields are being shown here for different purposes. So we can say that there are some health issues are there when we work with this nanomaterial, and health issues uh, are there when we are working with this, and also at the same time some environmental issues are also there, because nanoparticle could be accumulate in soil, water, plants, and traditional filters cannot do their cannot be separate or cannot be functional for this case. So our privacy can be affected, terror activities may increase, and therefore there should be some agencies that is known as the risk assessment method should be there, and national international level agencies can take part for to discuss the health issues and environmental issues. Terror activities may increase, and therefore there should be some agencies that is known as the risk assessment method should be there. There are challenges to the epidemic situations. Agencies can take part for
ಯಾರೆಲ್ಲ ನೋಟ್ಸ್ ಇರ್ತೀನಿ admin notes
so our ex-president and therefore APJ Abdul Kalam is that there should be peaceful thinking, thinking provide knowledge, and knowledge makes you great. So already we know that new science called intelligent bioscience, and now bio nano information technology can be useful field where development of nano robot can take place. And as we know, in 2 years back, the Nobel laureate in chemistry, they have synthesized a very thin, strong, world's smallest machine, which is very protective, very strong as compared to any other material, but invisible also and very thin. So now the challenges are also there. Nano robot. In the future, nano robot can work in different field, and also when they injected to the patient, they repair, and infected part can also be repaired and can be digested because it is a DNA base. So in the future, this technology have some challenges, and also the research scholar or teachers can do work on this field by using nanomaterial and in the field of nanotechnology, and they can do work in this field. So many areas are there, number of methods are there to synthesize this nanomaterial, and after that we have to characterize, and then number of application we have seen we can use for that. And also in addition to that, some green approaches is also there to avoid chemicals for the synthesis of this nano size metal oxide or metal, and these material can be used to fabricate or to make the robot or to fabricate some as per the society needs, and use some technique to characterize. So future strategy is there, and number of areas are there where in the mathematics, science, engineering or technological education where we can use this field and technology. So we can say that it is expected over the 20 years, nanotechnology will fundamentally transform science, technology, and society. So in the summary now, I can say that we have seen different types of nanomaterials, different field of synthesis of nanomaterials. After synthesis, what are the methods to characterize it, and different methods, and after that characterization, and what are the applications. Different field have different application of this material, but we should have to know the method, then characterize, and then we can apply that to particular field. So depending upon the application, we have to synthesize, we have to use them, we have to select the method of this material. So in this case, there is a large scope to do research or to do something innovative work. So this is the building of my college, Kamla Nehru Mahavidyalaya. Our college is A plus, having CGPA 3.53, NAC accredited. So having PG, UG, and post and also doctoral programs in our college. And total strength of our college is near about 8,000, affiliated to the RTM Nagpur University, Nagpur. Thank you. If any participant have queries, they can ask. Over to you, madam. Hello.
Dear participants, do you have any questions? Just go ahead.
Hello.
Hello, sir.
Hello.
Hello, sir.
Hello. Hello.
Sir, I have a question, sir. Hello.
Hello.
Sir, have you worked in graphene oxide, sir?
No, we are not working on graphene, but you can work on graphene. Graphene is a lot of carbon, and you can make the sheet of the graphene.
Okay, so I have a
This
doubt.
only work is going on that. So our field is different, okay,
Uh-huh.
but related to this one. Okay, now. We are working on the
Hello.
polymer. Hello.
Hello, sir.
Hello.
Hello.
Yes.
What is nano refrigerator, sir?
Nano refrigerator.
How
Word
does it work?
indicates word indicate refrigerator, na nano size, but no refrigerator such type is in the market. Okay, na.
Sir, means के refrigerator बहुत small होगा, बहुत छोटा होगा क्या, or something it has nanoparticles. It is just like that double door.
अब कम होगा लेकिन अभी आया नहीं है. It is not in the market. Okay, na.
Sir, नहीं मैं वो पूछ रही हूँ what is it? What is nano refrigerator?
Nano size means smaller size, na. Refrigerator you are saying it is a nano size, smaller in size, just like a nano car, na.
हाँ.
In the same way. Okay, na.
अच्छा. How will it work as compared to the normal refrigerator? What are its
No,
different
only they
functions?
are only no. Okay, they are only they are reducing the size. Okay.
It just reduces the size. Applications
Size,
are
yeah.
the same.
Working is as it is.
Applications
Functions
are the same. That working is the same.
Yes,
Are
yes.
not cycle.
What is the purpose of that fridge? For that purpose, we can use only they are making. But in the fridge, materials are using what is only the compressor like that, na other. Some part of that nano materials are
reduced.
they are using only the size, and our again what is we need the what is the fridge for of more capacity, na. So we cannot use that one.
Thank you, sir.
Other thing can be used.
Sir, I have got it. Sir, I want you to go for a second seminar on quantum mechanics, quantum chemistry. Sir, it is weak. My quantum chemistry is very weak. Please, sir.
So now there is a phenomena of quantum mechanics.
Sir, I want you to give a webinar on quantum chemistry.
Okay.
Sir, please arrange a webinar on quantum chemistry.
Okay.
So please update us.
Okay. That is different. Okay, na.
Thank you, sir. Thank you, sir.
Yeah.
Thanks a lot. I am from Kashmir, sir.
Okay, very good.
Thank you, sir.
Yeah.
Sir,
सर इस वेबिनार का सर्टिफिकेट मिलेगा?
Yes, you will get a certificate after filling out the feedback form. I'll send you the feedback form after the session to your mail, WhatsApp, and in the